No problem.
I'm sharing my screen, which I hope you can all see now. So yeah, as per Chris' words, my name is Joe Bombardi. I'm a solution architect covering the EMEA region. I focus specifically on Riverbed's storage-focused products, which predominantly the Granite technology, which I'm going to talk to you about today. We also have another storage-related product called Whitewater, which is more of a cloud storage gateway product, which would be a session for another time. So I'm going to carry on with the Granite message. So as some of you might be aware, a lot of Riverbed's technology has been focused around consolidation and enabling our customers to consolidate. That's typically around, effectively moving applications from a branch office into a data center and bridging the gap that would create, because obviously there is a WAN in between, which comes with bandwidth challenges, latency challenges, quality challenges, and so on. And that's typically where, I guess, the background of Riverbed came from and where the WAN optimization product line came from. Now, most of our customers do have a strategy to consolidate, and the ultimate goal is to achieve 100% consolidation for the obvious reasons. Obviously, you have a lot more control when all of your data and applications are in your data center. There's a lot less risk. You don't need to be concerned about infrastructure and data that might exist on a branch office somewhere. And it tends to be a lot cheaper having a consolidated infrastructure because you're effectively building one infrastructure and there's obviously an economy of scale in having one infrastructure which is built for purpose across the whole organization, as opposed to having to replicate the equivalent of mini data centers across as many sites as you have. So that's obviously the goal, and that's what everybody wants to achieve. But we've actually found that a lot of customers aren't able to achieve that 100% consolidation. They might be able to achieve a good proportion of consolidation and might be able to consolidate a lot of the applications out of the branch, the easy ones such as email and Exchange, that type of application set. But we do find that a lot of customers do need to leave some applications running at a branch office. Usually it's for performance reasons. Even with WAN optimization, sometimes the performance of LAN-like that you get with WAN optimization isn't quite enough. It could also be because you have some very specific custom applications running in the branch. There could be very write-intensive applications running at the branch. A lot of our customers fear the risk associated with the WAN being down or various other issues on the WAN where even with the best WAN optimization in the world, it's going to be rendered useless if there's a challenge on the WAN connectivity itself. So we find for one reason or another, some customers require to keep applications in the branch. And this is where the Granite technology was born from. It was a way of looking at why do our customers do this and what can we provide as a solution provider to deal with that problem. So a lot of these customers are left with the challenge between the strategy of full consolidation, which of course suits the business strategy and makes perfect sense, but that may come at the cost of performance to the end user at a branch office. And ultimately our customers are left with a scenario where if you are forced to run an application in the branch office, that of course means needing to have some kind of server infrastructure in the branch office. That of course means having to have some kind of storage in the branch office. Storage means you keep data in the branch office, and if you have data in the branch office, you need to protect that data through some kind of backup mechanism, which typically is a tape library or some kind of backup over the WAN type of infrastructure. So in order to support even just one application at the branch, it forces you to have a whole bunch of infrastructure in the branch that you would rather not have. And ultimately that's because where your compute is, in this case the branch, compute and storage are ultimately tied together and you have no choice there. So it's a case of application in the branch means you have to have all of that infrastructure. Or everything in the data center may leave you open to some performance challenges at the edge. And basically it means that you're left with these traditional challenges as to why most of our customers want to consolidate in the first place. And that's of course, as I mentioned before, having full control of all of the data, simplifying management, being in a scenario where you can centrally provision and manage all of your data and applications, backup and recovery. Again, being in a scenario where you only have one data protection strategy in the data center where all of your data is, as opposed to having a different data protection strategy for all of your branches because data lives in all of those branches. And aside from all of the complexity of all of that, you're left with a cost which is greater than what it would have been had you been able to fully consolidate. So to take a step back, for those of you that have come across Riverbed in the past with the Steelhead WAN optimization technology, you'll know that the aim of WAN optimization is that you have a client in a branch office and you have the application and storage in the data center. You have a WAN in between, you put WAN optimization in there, we do a bunch of compression, data deduplication, transport layer optimizations, protocol optimizations, application layer optimization, ultimately doing everything to mitigate the impact that the WAN is going to have on being in between a client and the application. And that's when you're in that fully consolidated situation. In the Granite world, we don't have those servers and storage in the data center. We have the servers and storage in the branch office. So the magic of Granite is ultimately that we're able to decouple the storage from the server. So that basically means the aim of what Granite is doing is to enable our customers to continue to run the compute, i.e. the application in the branch, which is what you want to make sure you have that 100% local LAN access to the data and the performance associated with that. However, previous to Granite, you of course could never consolidate the storage component of that because that would have been tied to the compute. So where Granite fits is we're enabling ourselves to consolidate 100% of that storage component into the SAN in the data center or data centers if there's more than one. And then we implement the Granite infrastructure, which I'll talk a little bit more as I go through this presentation. In this case, we have a Granite core appliance on the data center side. We have the Steelhead/Granite appliance on the edge. And what we've basically achieved is consolidating all of the storage that was previously associated with that server, but that storage is now in the data center, whereas the compute, i.e. the server application itself, is still in the branch. Okay, so that's the core difference between the legacy of Riverbed, WAN optimization, where you have a client in the branch, servers and storage in the data center, versus Granite, where you have the storage in the data center thanks to Granite, but the compute and application still running in the branch for that branch. And I'll talk a little bit more about how that actually works. So back to this consolidation message. So there are effectively three parts to the consolidation value that Riverbed provides. The first one is the traditional Steelhead WAN optimization piece, where our customers used to look like the top left, having all of those applications and servers up there in the branch. We then implement Steelhead WAN optimization, and we can consolidate a large chunk of those, but sometimes not all of those. The second part to this piece is what we call VSP. So VSP stands for Virtual Services Platform, and that's effectively a Riverbed terminology for the fact that we have a fully functional VMware ESXi hypervisor running on our appliance in its own partition. So that gives our customers the ability to, while they're implementing one of these appliances anyway, if there are any other physical servers running in the branch, why not consolidate those, get rid of that physical infrastructure, and run those applications virtually using the VSP component of Riverbed. That's now a full version of VMware. It's supported and accessed just like you would access any kind of VMware host. So it plugs straight into vSphere and vCenter, and it would be managed in the exact same way. Now, that's very nice on its own, but obviously the challenge here is that, as per the diagram, we still have all of the storage and data living in the branch, which means we haven't achieved the core component of that consolidation piece, which is where Granite comes in. So when we put Granite in, you'll notice that the storage is now being fully centralized into the data center, and that last bit of the animation there showed you that what Granite's actually doing, once the storage for that branch has been consolidated, it's projecting that very same storage back out to the branch Granite appliance, and that Granite appliance is presenting that storage locally. Okay, so this is crucial as for what Granite's doing. We're achieving two very important bits. We're consolidating the storage first, so it's in your data center where it's provisioned and managed with the rest of your SAN. Okay, so you no longer have to provision or manage or back up any data in the branch whatsoever. But crucially, through the Granite projection technology, all of the data blocks that live in that central storage are now presented at the branch just like they were before. So Granite is effectively presenting itself as a mini SAN, so to speak, presenting all of the block storage that was previously associated with that branch locally from the branch. And that will be presented there whether the WAN is up or down. So we're not talking about doing optimization to put that traffic, that data there. it lives in the branch in a stateless way and is presented from the branch in a stateless way. So as far as the clients on the branch are concerned, they now still have local applications. In this case, they're running from the VMware partition of our appliance, and all of the data associated with both the applications and any user data associated with those applications are presented locally via the Granite storage at the branch. And that's the win-win. So the branch still gets 100% local performance, while as an organization you achieve 100% data consolidation. So moving on, so what happens once we've got these pieces installed into the environment? You can see the blue appliance to the right, which is the Granite core. That effectively mounts the SAN, and it's talking directly with the SAN. The edge appliance is talking directly with the virtual machines and clients at the branch office. Now, all of the data is, of course, accessed from the branch. So as that data changes on the branch, and as it's writing to the Granite block storage, the Granite is immediately syncing those data changes back to the Granite core, which syncs them back to the central SAN. And that's the crucial piece as to why you no longer need any form of backup or data protection in the branch, because every time a block changes on the Granite storage at the branch, it immediately tells the SAN that that data block has changed. You need to update it with this particular information. So effective SAN is a matter of seconds behind what the branch looks like. And that has a dramatic impact on the RPO for a branch. Most of our customers will typically run a tape backup once a day at the end of the business day, which means that branch has a risk of losing 24 hours worth of data, assuming the backup is handled correctly, if there was something to go wrong in the branch. Whereas in a Granite world, if the Granite appliance was to fail, the worst case scenario is you've lost a matter of seconds, maybe a few minutes worth of data, because as I said, Granite is always immediately syncing those block changes back to the data center. So you're getting the equivalent of data center class RPO, or data protection, for a branch office. And you would, of course, never invest data center class tools in a branch office because of course, of the cost. So there are two modes the Granite Edge can work in. The bottom one there we call pin the lung. What that basically means is once the data is consolidated and lives in the SAN, 100% of those data blocks are projected out to the Granite Edge appliance and presented locally. So as I said before, that means that the Granite has no reliance on the WAN whatsoever as far as the way it serves up data to any of the virtual machines requesting the data at the branch office. So that means that the servers running at the branch will never need to make any form of request for a block over the WAN. WAN could be up and down, has no impact on the way Granite performs. And that's the usual way most of our customers deploy Granite. The other option is to use the top mode there, which is called working set. So what we have with a lot of customers is they say we're running a Windows server for file and print functionality. So with Granite, we're doing two crucial bits there. One, we're hosting and projecting all of the files that make up the Windows virtual machine itself, which means we're centrally provisioning and projecting the operating system over the WAN, which I'm going to talk a little bit more about later on. The other thing that they're using Granite for, of course, is there'll be a file share or a number of file shares for that branch office. So a lot of customers will tell us that if, for example, they had 2 terabytes worth of storage for a file share for that branch, the users are typically only accessing a very small subset, usually 10, 20% of that data on a regular basis. So using a working set mode allows the Granite to cache the most actively used blocks from the branch office at the edge, which means almost always when a block is being requested from the Granite Edge, it's being served from the Granite Edge. On the occasion that a block doesn't exist on the Granite Edge because it could be some very old data, that Granite Edge then requests that block from the Granite core. Now, in the next slide, I'm going to talk a bit about what Granite does to make that process seamless to a user. But there are these two sets. So the value of the working set mode is rather than using a large amount of storage space on the Granite Edge for a lot of data which might never be accessed, you can get away with using a smaller appliance with smaller storage space and use a working set mode instead of a pin mode. Or you can use a combination of both. And that allows you to get away with a smaller appliance. It's a similar concept as using, thin provisioning, I guess, as far as making sure that although you're not hard setting that much storage to be used on an appliance, you do have access or you can address total amount of storage space that you're actually configuring to start with. So what does that mean when we've implemented all of this? So as you can see, we've centralized the storage that now lives in the sand. We've put the granite pieces in. You can see there are three components there. So there's the granite core, which mounts the storage, as I mentioned before. There's the granite edge, which is doing WAN optimization, VMware, and granite. And we still have a separate steelhead WAN optimization appliance. So if you want to optimize the granite sync traffic or any other client server traffic going over the WAN, you would still need a steelhead WAN optimization appliance on the data center side, whereas on the edge you would still have just the one appliance to do all of those components. So granite predominantly being storage, of course, is serving up reads and writes to any application that's configured to talk to it as its storage. From a writes perspective, anytime an application running at the edge writes, it always writes to the local granite disk, regardless of mode. That goes through an SSD layer on the appliance, and it's always acknowledged locally, again, regardless of mode. WAN, up or down, makes no difference to this particular process. That granite edge, of course, then, as I mentioned before, it asynchronously sends the change back to the data center to update the SAN on what that data write has actually done to the block. Crucially, the edge is the authoritative owner of the data. Because now you have the same data in two locations at the same time, it's crucial that logically we're not changing the way data is accessed, which means you still can only access data from one place, in this case being the edge, whereas from the data center you're only managing and protecting the data. So you manage it from the data center, access it from the edge, which means you never have any risk of any data integrity or data coherency issues as you would if you're using various forms of file caching engines and various other methods of doing what sounds like a similar process. From a read perspective, if those LUNs are pinned, as I was talking about in the previous slide, then again, those reads are always 100% served up locally from the branch, regardless of whether the WAN is up or down. If you're using the working set mode, if those blocks are in the storage on the edge, they're served locally. Whereas if a block is requested from the granite edge, which it does not have, it will then request the block from the granite core. And this is where some of the granite core functionality comes into form, because granite core is able to make a relationship between all of the blocks that live on a SAN, on the LUNs which are being projected out. It understands how all of those blocks are related to each other because it has file system awareness for VMFS and NTFS file systems. So if, for example, a user at the branch opens a 20 meg file and that file is 2 years old, hasn't been accessed for 2 years, and the granite edge does not have all of those data blocks, it will request the first block from the granite core. The granite core will understand that that block is part of a specific file. It understands the rest of the blocks that make up that file. It then prefetches them, pre-populates them in an accelerated manner over the WAN. So by the time the granite edge is requesting subsequent blocks, those blocks are already at the edge. So performance-wise, it's quite negligible to what a user would see. The only risk there, of course, is if the WAN happens to be down while somebody accesses a very old amount of data while it's in the working set mode, then of course there would be an error or a read error. And that's a risk most customers are willing to take because the odds of all of those happening at the same time is going to be very rare. So the two components, Granite Core, which can be a virtual appliance or a physical appliance. The Granite Edge is only physical, which has those three components I mentioned earlier. I'll skip through this quite quickly, but the different Granite Cores are able to address various amounts of storage to project out from a SAN and various amounts of branches that any appliance can support. The Granite Edges vary from as little as 380 gig worth of storage all the way up to 10 terabytes worth of storage. And as you go through those ranges, you can see that there's also resilience built in with dual power and RAID. There's also different amounts of compute with RAM and CPU power between all of the appliances, which of course would vary depending on how many virtual machines you would be running via the appliance at the edge. Now, when I say that the largest appliance can address or has 10 terabytes worth of storage, if you keep in mind that working set mode or the working set cache mode that I mentioned before, 10 terabytes of actual storage in a Granite Edge could quite easily address 50 terabytes worth of storage from a SAN. So these edge appliances are very, very scalable and would scale up to very, very large branch operators on the edge. I won't spend much time on this, but this is just explaining what the appliance looks like on the inside. So to the left, you can see the Rios WAN optimization operating system. That's the traditional OS that we've always done for WAN op. You can see the VMware ESX kernel that's built on top of the appliance, and then it just gives you various examples of what type of virtual machines you might want to run on the appliance. As I said before, in most cases, it's just Windows file and print, domain controller, AD type functionality. Some customers might run databases or some specific customized applications for the branch. So what it all looks like, again, once you've implemented it all, to the right, you can see two Granite Core appliances in HA mode, in full high availability mode, talking directly with the SAN. They can talk iSCSI or fiber channel. On the Edge appliance, you can see it's just serving up iSCSI disks to any virtual machines running on the VMware platform on the appliance, or also to any external server host, which are also getting their storage from Granite, which is also possible. The blue dotted line in the middle is a Riverbed proprietary protocol, which is used between the Granite appliances, and that's been designed to be very, very optimizable to make sure it gets full levels of deduplication and acceleration across the WAN. Now this piece here is a very, very important part of what Granite value can also be added as a byproduct, I guess, which is very, very fast server provisioning. So for most of our customers today, if they have to provision servers at a number of branches, that would involve sending staff out with usually physical servers or maybe to virtual servers, installing applications, provisioning storage, provisioning data, mapping it all up together, making it functional for the use on the branch. And that typically takes, 2 to 3 days per branch on average when we talk to most of our customers. In a Granite world, because applications and storage are now always provisioned centrally, all of that job becomes a central job rather than a distributed job. So what I mean by that is, if you had to provision, let's say, a Windows server at a branch, what you would do now is you would connect locally from your HQ to your SAN. You would provision a LUN, okay, so just like a logical area of storage on that SAN. Within that LUN, you would locally copy all of the files that make up a virtual machine for a Windows server. Okay, you would then map that LUN out to the relevant branch, Granite appliance that you're talking about. And once you map it all through, which I'm about to show you in a demo, you can then boot that server over the WAN. Now, once it's booted over the WAN, it's going to all of the data for that application is now going to be running from the Granite Edge appliance, which means that the application is now running from the branch, even though it originally was provisioned in a data center and projected out. It's projected, it runs 100% from the branch, just as if it was a locally provisioned server. Now, that booting over the WAN process could sound scary, but again, part of the Granite value is, I mentioned that algorithm before where the Granite Core appliance knows how to make sense of how all the blocks in a SAN are related to each other. So when we first request a power on from the branch VMware, it's going to read, or it's going to request to read a block, which is going to be the first boot block of a Windows server. The Granite Edge at this point won't have that block because, of course, we've only just provisioned that server in the data center, so it's going to request the first block. It won't have it. It requests the first block from the Granite Core. Granite Core looks at that block, and it knows that that block is part of a Windows Server boot process. So it goes away and calls only the blocks that are part of a Windows boot process, which is actually quite small. It's only about 200 meg worth of data. That 200 meg, of course, gets passed through the WAN optimization, which may mean only sending about 20 meg worth of data over the WAN. And on quite a slow WAN, i.e. about a megabit per second, 100 milliseconds, that Windows Server will have booted in about 5, 6, 7 minutes or thereabouts. So if you were in a scenario where you had to provision a server, in less than 20 minutes, you could have that server fully functional at a branch office doing whatever it's being required to do at a branch. And that saves a lot of time in that provisioning process. And that's part of the value, especially from an ROI perspective, of what Granite does. It's not just about removing servers and storage and backup infrastructure from the branch. And there is, of course, a very good ROI to be had versus all of that. But if you also think about the fact that it dramatically reduces RPO at the branch, it dramatically reduces the time to provision servers at the branch, And then the same applies from an RTO perspective, again comparing to our customers where if servers and storage and backup fail in a branch, that firstly means a bunch of data being lost, and secondly it means you need to go out there and re-provision all of this stuff again, which again could take days, in some cases weeks, for some of our customers, especially by the time they recover all of the data. In a Granite world, a new appliance goes to the site, it's all mapped through in the way I just mentioned, and then you can just power that virtual server over the WAN again. 10 minutes later, you're up and running. Keeping in mind, not only are you up and running 10 minutes later, but you haven't really lost any data during that failed process, which means we're dramatically reducing the RTO for a branch office as well. So it's quite an important part of what Granite does for you. This slide here just shows some comparisons of if you were to boot a Windows server locally, it's normally 2, 3, 4 minutes, depending on the quality of the server itself. A Granite cold boot, so that's part of the demo I'm about to show you. You know, depending on the WAN, can take anywhere from a few minutes to 7 minutes, 10 minutes, thereabouts. But that's dramatically faster than, of course, going out to a site, provisioning a server, patching it, upgrading it, provisioning storage, and so on, and making it available to the branch. A Granite warm boot is where it's making use of some of the byte level cache in the WAN optimization component of the very same Riverbed appliance. A Granite hot boot means, you know, the Granite appliance was already hosting or presenting that centrally provisioned server locally. You now reboot it. All of those blocks are, of course, on the Granite edge storage in the branch, so it boots up very, very fast. And the quality of the Granite appliance or the Riverbed appliance is typically higher than your typical branch office server. You know, we have high-quality SSD, high-quality disk with high amounts of IOPS and compute power, so it does boot up quite fast. And of course, if you try to do an iSCSI boot over a WAN without Granite technology, it would effectively time out eventually. It just would not work. So I'm going to show you a very quick demo. The idea of this demo is to show you the process of centrally provisioning storage, centrally provisioning an application, in this case a Windows server, mapping that out through to a Granite Edge appliance and the VMware running on a Granite Edge appliance, and then booting that application server over the WAN. So the idea of that is, of course, that once that application server has booted over the WAN, it's running locally, it's doing everything locally at the branch, and it's effectively performing the same way as when you already have an application server running in the branch. Now, the reason I've got this diagram is to explain what the environment looks like. So the demo I'm doing is actually from my laptop. It's connecting into infrastructure in our Riverbed headquarters in San Francisco. So this is over a, you know, not a great quality internet connection from my laptop using a VPN into HQ on the other side of the Atlantic in San Francisco. In San Francisco, I have a NetApp storage array. I have a virtual Granite core running on that side. I also have a virtual Steelhead running on that side for the WAN optimization piece. I've created 2 LUNs on that NetApp, which I'm presenting out to the Granite Edge appliance. Now, on the edge, what I effectively have is a VPN client, which is making the connection back to HQ. I'm running the Steelhead mobile off my laptop, which is you know, simulating the WAN optimization component of an appliance. I then have a virtual Granite Edge running, which, you know, isn't a product we sell. We use it just for demos because, of course, Granite runs on a physical appliance only. And then I have a virtual VMware running on my laptop as well, which is what will effectively host the compute once I've booted the Windows server over the WAN. So I hope that makes sense. I'm now going to switch across to my demo environment. So log back into that. Okay. So this VMware that I'm logging into now is VMware just running on my edge side. Okay, so this is simulating, I mentioned before, what we call VSP. So this is simulating VSP running on a branch side appliance. This host you see on the top left, that's my physical Granite Edge appliance, or it's the VMware running on my physical Granite Edge appliance. Now I'm going to show you the web interface to the Granite environment. So to the right here, the screen is seen now. Apologies, I've put the right password in. Try again. Doesn't work either. There we go. So on the Edge appliance, obviously, as part of the consolidation message of Granite, we want to make sure that not only are we putting our customers in a scenario where all of the data and storage is centralized and the provisioning of servers and data is centralized, we of course want to make sure that where possible, all of the configuration from in a Riverbed world is also centralized. So you might be familiar with what we call CMC, which is the Central Management Console. That can integrate into Granite as well. From a Granite Edge perspective, there is only one component to configure from a Granite perspective, and this has been pre-configured by myself, but basically we tell the Granite Edge appliance the IP address of the Granite core appliance that it needs to talk to on the data center. So in my case, it's 10.32.147.169 is the address of my Granite core. I'm also telling the Granite core what the identifier is for my Granite Edge appliance, which in this case, I've called it Edge 17. That is the only thing you configure on a Granite Edge appliance. And that's also very important when, I mentioned earlier on, if a Granite appliance was to fail, we need to make sure that things are up and running as quickly as possible. That would be the only bit of configuration required on that branch office. And that, of course, can be exported by the CMC management system as well, if you need it. Now, on the Granite core side, you can see I have various things to consider or to configure for Granite. All I've done here is I've told my Granite core the IP address of my NetApp storage array, which in this case is the .161 address. You can see the port being used here, 3260, is just the iSCSI protocol between the Granite core and my NetApp system. The LUNs, so these are the LUNs that were configured on the NetApp to be projected out to the branch side. So I have two LUNs. The reason I've called them C drive and D drive is the way you would normally, for example, provision a Windows server is you'd provision a C drive volume on that server to host the operating system itself, and then you'd provision a D drive or an E drive, whatever you'd normally call it, which would host the user files, the data, the file shares, for example. So the reason we like to separate it this way, it means you can manage both of those LUNs separately. It also means that the LUN which is hosting the Windows server, you would go into that pinned mode. The reason you'd want to be in pinned mode for that LUN is to make sure that that operating system always works 100% of the time, even if the WAN is down. The WAN could effectively be down for days, and that Windows server or whatever application server it is would still continue to run seamlessly because all of the data blocks it needs to run the operating system are being presented on the Granite Edge from the edge in the branch office. Whereas if you were going to use that working set cached mode for the file shares, you could keep that on a separate LUN, and you would say that that LUN will be working set as opposed to ping. It also means you could manage them separately. So again, one of the values of Granite is, let's say you had 50 branch offices with 50 servers in those branches or across the branches. If you wanted to patch those servers, as opposed to manually having to patch them from the branch at the branch, you would ultimately just unmount those LUNs from the Granite Edge, just the operating system LUNs, not the data LUNs, mount them from your data center, patch those operating systems locally or upgrade them or put a new golden image in, map them back out to the Granite Edge, power on and boot over the WAN again, and you've just patched 50 servers in a matter of minutes as opposed to however long it might normally take depending on what infrastructure you have. So in my case, the C drive, when I provision that C drive on my NetApp, I copied the Windows VM files from the central side locally into the NetApp storage to be presented out. And the D drive was hosting the file share volume basically, which would be accessed locally once it's all up and running. Then I told my Granite core that these two LUNs that I've provisioned belong to what I called Edge 17, as you may recall from the Granite Edge configuration screen. And because basically in the real world you would have a large number of LUNs potentially, you need to tell the granite core which LUNs belong to which branch effectively. And that's basically what I've done over here. There's some iSCSI configuration to be had as well. So for those of you familiar with iSCSI, you'll know that there are iSCSI initiators and iSCSI targets. So no different here. We're basically telling the LUNs which iSCSI initiators, in our case, the VMware host, which you can see down here, or on the D drive LUN, the initiator is the Windows IQN. And that's basically from a storage perspective, telling those LUNs which iSCSI devices have access to those LUNs. And that's making sure that we don't not only have security of those LUNs, but we're not being in a scenario where you have multiple devices accessing that LUN, because that, of course, could cause issues from a data integrity perspective. That's effectively the extent of the Granite configuration. Once that's all mapped together and you've mapped it out to the Granite edges, you basically see that there's a connection between, as you can see here, between the Granite Edge appliance and the Granite Core appliance. If you had high availability, you would see all of that on your screen as well. So at this point, the Granite Edge is presenting those two LUNs at the branch. But now we need to tell the VMware component running at the branch that it needs to get its storage from Granite Edge. So if I now go to my VMware configuration, as I said before, this VMware screen you can see now, that is the VMware host running on the Granite Edge appliance. And just like any VMware host, you need to configure it so it knows what storage to use for where it's going to get its data from. In our case, we're telling that VMware host we want it to get its storage from Granite. Not from its local disk, even though it's using the same physical disk. Logically, we're telling it to get its disk from the Granite projected LUNs as opposed to using local storage. And that means two things. It means all of the data it's accessing, both for its virtual machines and data in general, originally was provisioned in the data center and was projected out. It also means as VMware or whatever virtual machine or application is accessing that data, and as that data changes, Granite does its normal job of identifying every time there's a block change on its storage and immediately syncing that block change back to the data center. And that's why we need to map it together. So in this case, I've told my VMware storage to be Granite. Okay, now if I was to browse the data store, that's going to search its data store, and you'll notice that even though the Granite Edge appliance is empty in the first instance, because I'm browsing that data store, it can see everything that the Granite Core can see in the data center, which in this case is the virtual machine for a Windows 2008 server. Okay, now if you look inside a virtual machine, these are all the files that you would see, of course. A .vmx file, which is the configuration file for that server, I would effectively right-click that and say, I want to add that to my local inventory on my VMware running at the edge. So as far as the VMware running on the edge appliance is concerned, that virtual machine lives locally. It does not know whether the blocks or the data is there or not. It knows that its storage is there. As far as it's concerned, all of it's there because Granite's telling it everything is there. Granite takes care of whether it serves data up locally or needs to call it from the other side of the WAN in the event of a data block not being there. So that's how you map the Granite storage to the VMware running on the edge appliance itself. Now if I look down here, I've now got, ignore that top one, that's just my virtual Granite Edge running here, which wouldn't normally be the case in the real world. But you can see that in the local inventory on this Edge VMware, it believes it's got a local VM for a Windows 2008 server. Now I'm going to go ahead and power that server on. Now when I power that on, the blocks required are not in the Granite Edge yet. Now in this case, some of them are here because I've done a test run on the demo before the presentation to make sure the environment was up and running. But most of the data blocks will not be in the edge, which means the edge needs to call the data blocks from the Granite Core. Okay, and this is going to do a boot of a Windows 2008 virtual machine over the WAN. Also note that the LUN for this, it doesn't show it here, but the LUN size for this appliance is about 20 gig. Actually, it's you can see here it's 40 gig in this case. Now, as I mentioned before, we're not booting 40 gig worth of data over the WAN to make this functional. Granite will only request the blocks it needs to serve the request that it has, which in this case is to boot a Windows server. So I'm going to go ahead and power that on. And I'm going to look at the console of that appliance in the background. Now, you can see in the background it's just finished the process of the request. You can see VMware's doing its job in the background. Now again, depending on the quality of the WAN, the bandwidth, the latency, packet loss, the level of optimization we're getting from a WAN optimization perspective, and also depending on how many of the required data blocks are in the Granite Edge storage, this will take anywhere from a couple of minutes to 5, 6, 7 minutes to 10 minutes. You can see in this example it's going to be quite fast because it's already got enough data blocks to show the background boot process for Windows. That's because, as I mentioned, some of the blocks would have already been in the Granite Edge cache, just so we're not sitting watching a blank screen for the whole time. Now, while that's booting in the background, if I go to the Granite core, there are a bunch of reports that show what's actually happening in the background. Now, these reports allow our customers to see everything going on from a storage perspective. So you can see, the amounts of data being requested over the WAN, the amounts of data that is still waiting to be synced back. It shows you everything you would want to know from a storage perspective as far as what impact Granite is having, the amount of storage being served up from the local cache, the amount of storage which is having to be requested over the WAN because you're either in working set mode or you're doing something for the first time, like booting a server over the WAN, as I'm doing now. Some of the reports that our customers like are you can see the prefetch throughput, but you can also see, let's go across to this report over here. Okay, you can see the throughput rates of how much is going from a write perspective and a read perspective. It can show you I/O latency, I/O, IOPS. It'll show you the metrics on a per LUN basis as well, as you can see over here. You can choose which specific LUN you want to talk about. So I'm changing that to the C drive LUN. If I look at the reports on the Edge appliance, now, these block storm metrics tend to be our customers' favorite reports because I mentioned before that Granite plays a huge part in reducing RPO. So a lot of our customers like to look at what we call commit delay. So the commit delay, in this case it's showing you just 2 seconds, there's very little data to write back at this stage. That commit delay is showing our customers how much data has been acknowledged and from the Granite Edge storage, i.e. an application has written something to the Granite storage. How long is it going to take for Granite Edge to sync that change back to the Granite core appliance and get an acknowledgement and a journaled acknowledgement from the Granite core from the SAN? So that number you see there is effectively your RPO at the branch, which in this case, again, is 3 seconds. As I said, in the real world with real data and real activity going on, that might still be in the seconds. Usually it might be in the few minutes range. In a very bad quality WAN, it could be 30, 40 minutes or thereabouts, but it's usually a matter of seconds or minutes, as opposed to what is, as I said earlier on, at best, a 24-hour RPO that you typically have in that branch. So that appears to all be, functioning good in the background there. As you can see in those few minutes worth of just showing you those graphs, what you see in the background is a Windows server which has fully booted and is running at the branch. So I'm going to just log in. Now, because the Windows server is still requesting blocks for the first time, every time, whatever the Windows application itself is doing in the background, anytime, because of course it's always trying to read, because as a Windows server or any server, it's always doing bits and pieces in the background, it's continuing to call blocks from the background, from the Granite Edge, which continues to call those blocks from the Granite core on the data center side. So if Windows is requesting a block which is on the edge, it will be served up from the edge. If it's requesting a block which the Edge doesn't quite have, the Windows itself doesn't know that Granite Edge doesn't have it, because Granite Edge goes away and does all of that block store acceleration, pre-population, and pre-fetching that I mentioned before to get that block, as well as any associated blocks to the Edge as quickly as possible. My VMware host in the background just, the clients died there for a minute, as you could see, but the Windows will still be running somewhere in the background here. Here we go. So I'm going to say activate that later. And so as you can see in the background there, that's Windows continuing to load and boots in the background. Now, as that Windows is there, as I said, it's functional from the branch. If there was users in that branch that have mapped drives to that server would be visible just in the equivalent as if there was a real server in that branch office that had just been powered on. So everything to a user in that branch is 100% local. They have the equivalent of a local Windows file server. They have the equivalent of local file shares in that branch. Everything is local, but as you could see from the demo, that Windows operating system was originally provisioned in the data center only. It was mapped out through all the Granite core and edge functionality as I showed you, and then it presented itself locally in the branch as a branch type application. Okay, and I hope that makes sense. Now at this point, once this Windows server is up and running, we would basically use the iSCSI initiator within Windows to say, okay, you also have another volume that we want to map to. In this case, it would be that D drive LUN/volume that I mentioned before, and that D drive volume would host, the file shares, which again were originally provisioned from the data center, but are now presented out locally in the branch for the users to access locally. So for all intents and purposes, it's a local server with local data, with local storage, but what Granite has actually done is it's actually taken away the local server, the local storage, the local data, and the local backup and data protection. No compromise, basically. Okay, so I'm going to flip back to this slideware over here and just summarize some of those points before we make a bit of time for some questions. So reiterating the initiatives that Granite is here to enable, starting from the bottom left there, the obvious is, of course, as I mentioned, eliminating any need for server storage or backup or any form of data protection or licensing or, support and maintenance from a branch office, keeping everything 100% centralized. There's no compromise here. So the reason I always reiterate this point is obviously doing things from a WAN optimization perspective. You're centralizing servers, but the compromise is that you're getting LAN-like performance as opposed to LAN performance. In a Granite world, we're taking WAN optimization to a whole nother level by actually providing local data through the Granite projected data as opposed to accessing data over the WAN in an accelerated way. So there is no compromise. It's win-win. You're centralizing, but you're not doing that at the cost of performance at the branch. The enabling of disconnected operations is crucial because, again, if the WAN is up or down, it makes no difference to Granite. Granite just continues to plug away in the background, serving up reads and accepting writes and doing all the stuff that any server, storage, or VMware would normally do if it was located at the branch. Another crucial point, it is still a stateless branch. So although we're serving up and presenting data locally at the branch, it's doing so in a stateless way because that data actually lives, originates, and is provisioned from the data center and is projected out. It's presented locally, but it's stateless. So if the appliance was stolen or it's broken or it gets smashed up or whatever may happen to any kind of data at the edge, it's irrelevant. You don't lose anything because all of that data is still happily protected in the data center in effectively real time to what was happening in the branch. And that still gives you the branch survivability. So again, you've got local access to data, everything runs if the WAN's down. If the appliance fails, you don't have to wait days or longer to have, it's a matter of minutes or hours to be back up and running. And by the way, while you would be waiting for an appliance to turn up at the branch office to be replaced, you can just reconfigure Granite so all of those virtual machines and its data will be spun up on the data center side instead, so users can just access it over the WAN when the appliance is plugged in and boots it up and mapped and so on, and presenting all the data locally again, they would just then access it locally at the branch as they were before the failure. So you get full branch survivability here. And that tends to play a big part in, a lot of our customers who, for example, might be in construction, manufacturing, legal, retail, finance, where you're running systems that must function 100% of the time, whether the WAN is up or down. And then just very quickly on the Granite ROI, because this is crucial. So there is a great ROI to be had for Granite versus the usual infrastructure, server storage, backup, and all the associated license, support, maintenance, and so on. An important part of the Granite ROI also comes from the fact that if you were to add up the IT cost and the IT hours of staff to go out and provision and manage and patch and upgrade and protect, doing tape library stuff, vaulting the tapes, the time it takes to recover in the event of a failure, the hours lost in productivity if servers and storage and data were to fail. When you add up all of that cost, the ROI for Granite is really, really quite significant. So most of our customers who fit the profile, i.e., have some of this infrastructure in the branches, the ROI tends to be a no-brainer for Granite, especially when you consider if you do need WAN optimization on top of that as well, and that can also come from the very same appliance. It does become a very, very good ROI. So with that, I'll ask Chris to open up the session to questions. If there are any questions, I will have to take those. I'm not sure if you want to type those into the question bar or if we can do that via the audio.
Yeah, that's excellent. Can you hear me, Joe?
I can.
Perfect. Okay. Yeah. Okay. Thanks for that. That's fantastic. Yeah, as Joe said, if you do have any questions, if you can pop those into the chat box, and we'll raise those up for you. Obviously, if there's any further information that you want down the line, just drop us an email. You see the email address on the screen there, and we'll get back to you as soon as we can on those specific questions. In the meantime, just whilst we're waiting for any questions to come in, I've got a couple of questions which I guess people are going to be wanting to know, Joe. What sort of capacities are available at the moment in the edge, and what sort of roadmap is there going forward for the sizes of the data that can be stored on edges at present? Sure.
So the largest appliance we have today has 10 terabytes of usable storage for Granite. Now, I use that term usable as a key point because that means that Granite can hold a full 10 terabytes worth of data at the edge. But if you're using that working set mode that I mentioned earlier on, you could, for example, have 50 terabytes worth of data which is specific for that branch, but you only need to hold 10 terabytes worth in that cached mode. But the rest of the 40 terabytes is still accessible using that Granite prefetching, pre-population functionality that I mentioned. That appliance we call the 1360 is a recent addition. Previous to that, the largest appliance is 4 terabytes, and we found that some customers were requesting larger local storage for the appliances, so we released that. And as we see a need for larger appliances in the branch office, we will of course continue to grow that. But it's important to note that the Granite Edge only holds storage which is specific for that branch. It does not, effectively replicate your SAN out to every branch. It's only for the branch-specific data. So we find, 99% of the time that 10 terabytes is usually far too big. And, a lot of our customers tend to be more around the mid-range of appliance where they're looking at usually, 1 to maybe 3 to 4 terabytes for most even large branch offices.
Okay, that's excellent. And to follow that up, really, I guess there's pretty big capacity there. But in terms of scaling and size, did they go for the standard Riverbed trial option with this, where it's a try before you buy, so you can size them and make sure they're right-sized from the outset, or what sort of trial method is there behind this?
Absolutely. As with all of our products, we offer them fully available for proof of concepts. So, we make the appliances available. We, of course, work very close with our partners and yourselves to make sure that process is fully supported. From that, you would, integrate it into the environment. You'd test the, most of our customers might do a full production test or some kind of side production test where it's not impacting, production systems and so on. And we would show the full functionality of Granite in the, centrally provisioning and projecting of application servers, essentially provisioning and projecting of data for the branch. We'd also show customers the fact that the data no longer needs to be protected or backed up from the branch, because that would all now be done from the data center, because of course the branch data lives in the data center now. So we'd run a full proof of concept to make sure that our customers see the full functionality and requirements, and hopefully grow from there.
Okay, that's excellent. Thank you. Yeah, there's one question coming in, which is from the chat. It's to do with clustering. What HA or clustering is available in which modes, both either the edge or in the core, please?
Okay, so both core and edge have full HA functionality. So in the core, you can put, for example, 2 Granite cores together. They'll work in a full active HA mode. It's completely seamless. They share all of the same metadata and data block mapping. So if one of those appliances was to fail, the other one would seamlessly take over. With no impact to any of the Granite Edge appliances, of course. You would then swap out the broken one. It would then sync itself with the previous, the other active appliance, and just carry on in an active mode. On the Edge, we also have full HA. By the way, both core and Edge also have full MPIO, which usually goes hand in hand with HA as well. On the Edge, you would have 2 appliances in an active-passive mode, in which case writes are always written into the active appliance. That write is then sent to the passive appliance and acknowledged, and then the acknowledgement goes back to the originating server. That means that the data storage on both Granite Edge appliances is always 100% in sync. Again, if the active one was to fail, the passive one would seamlessly take over. You can also integrate full VMware high availability into this as well. Assuming you're using the VMware partition of the very same appliance, and assuming you have vCenter to manage high availability, that would all just spin up on the passive Granite/VSP appliance. So you've always got full HA between the appliances. From a clustering perspective, if you got to the point where, let's say, the largest size appliance at an edge or even a core was not large enough, you can then start, scaling horizontally to effectively, double the capacity by putting a second appliance in just for capacity reasons. But you would choose, if you had 2 appliances, you would be doing that either for HA purposes or for capacity purposes, not both at the same time.
Okay, that's great. Yeah, and there's one more question just before we wrap up. It says, you mentioned iSCSI. What availability is there going to be for Fibre Channel?
Good question. So we support Fibre Channel and iSCSI. At the branch, it's always iSCSI because it's all happening effectively internally, within the appliance. So that's just internal iSCSI, and that will remain that way. The Granite Core, of course, it's much more important that it supports Fibre Channel. So we support both. The way we do it today is the physical Granite Core supports iSCSI only. The virtual Granite Core supports iSCSI and Fibre Channel. So the virtual Granite Core would sit on top of an ESX host which has a Fibre Channel HBA, and we effectively piggyback off that, and we have full understanding of Fibre Channel in order to do that. We will eventually release a Fibre Channel physical Granite Core, but we find today that having full virtual support for that is doing the job for us.
Okay, that's perfect. Thanks ever so much for your time, Joe. As I said before, the email address is on the slide there, info@layer47.com. So if anybody has to think about things and decides they want to get some information or a question afterwards, or you'd like to go for a trial, please drop us a line at info@layer47.com, and we'll get back to you as soon as we can. Again, thanks for your time today, Joe, and thank all the attendees for joining and taking the time to listen to us today. Okay, thank you.
Thanks.